Okay, hello everybody. So today we're going to continue our discussion in simplifying radicals, and we are going to move into simplifying radical expressions that also have variables. So the first thing that we need to be aware of is that when the exponent of a variable inside a radical is even and its simplified exponent is odd, you must use absolute values. So here's a couple of examples of what I'm speaking of here. So if you look at this square root right here, you can see that the exponent inside has a 2. That number is even. When it is simplified by the radical, which I'll go over why that happens, it does turn into x to the first power, which is odd. So we went from having a 2 to a 1. So it went from being even to being odd. When that happens, you must put a set of absolute values around the variable that was simplified. If you look in the next one, you can see that this is an odd value inside, so we don't need to bother with worrying about absolute values. The next one here, it started as a 4, but when it was simplified, it stayed even, so we don't need to worry about absolute values there. But if you look at this one, we have x to the 6th, and when it simplifies from x to the 6th, it simplifies into x to the 3rd. So because it went from being even to being odd, you need to include absolute values around that variable. So utilizing that rule to simplify these algebraic expressions, let's take a look. Now, this number right here is 54y. Now, the variable itself is y to the first power, so we actually aren't going to have to worry about doing anything to that. If you recall that radicals simplify squareds, so because it's only y to the first power, we don't need to worry about anything being simplified. 54, however, does have a perfect square hiding in it. So if we were to break this up, this would turn into 9 times 6 times y. And we could look over those numbers. We could individually square root them if we wanted, or we could recognize, okay, 9 is rewritten as 3 to the second times 6y. Now remember, once you have something rewritten to a second power, a square root cancels a squared. So we're going to cancel that square, underline that 3, and then that 3 will come out of the radical. So what we will be left with is 3 square root 6y. And there's our final answer. Now, the next one we have here is we have square root of 90f to the second. Keep in mind, square roots, these numbers here, these square roots, cancel squares. So we want to always rewrite these so we have things that are being squared underneath. So if I look at this, 90 will break up into 9 times 10 times f to the second. Now what we're going to do is we will cross out every power that is squared as soon as we rewrite 9. 9 is rewritten as 3 squared times 10 f to the second. Now what you see here is that the square root will cancel out the squares. So that gets underlined and then canceled. This gets underlined and then canceled. The square root is canceling those. So now everything that's underlined will come out of the radical. So we'll have a 3. And we are going to write an f, but recall what we said up here. If the variable has a power that is even when it's inside the radical, and then it's odd when it comes outside, you need to put parentheses or absolute values around it. Excuse me, not parentheses. So this f started as f to the second, and now it's f to the first. So it started even, it's now odd. So we have to put absolute values around it. The last thing is we still have the square root of 10. The 10 is not removed from there because it's not a number that's squared. And there's your final answer. 3 times the absolute value of f times the square root of 10. So we'll try another one here. We'll go with this one right here. We have the square root of 32 times h to the fourth. Now, once again, we want to rewrite these so they are numbers that are squared. So 32, we will write 32 is 2 times 16. And then I'm going to break up h to the fourth like this, h squared times h squared. Now, why did I break it up like that? Well, I am trying to rewrite these so we have numbers that are being squared. Because when we have numbers that are being squared, the square root will cancel those. So we will underline the 4 now and cancel out the square. Underline the h, cancel out the square. Underline this h, cancel out the square. And what you see is everything that is underlined will be brought outside of the square root. So let's go ahead and do that. We have a 4, and then we have an h, and we have another h, and then we're left with 2 inside that did not come out. Now the two h's do multiply together, and we end up with h to the second, just like that. Now you might say, well, they started out as h to the fourth. Do we need to put absolute values around that h? And the answer is no, because we started out as h to the fourth, but once it came out, it is still h to the second. So it remained even, so it is not necessary to use absolute values here. So you can see our final answer is 4h squared times square root of 2. Now, here's one that I want to go ahead and try breaking up. You can see we have the number 289. Um, 289 isn't super obvious how it can be divided, I don't think, anyways. So, what you would want to do is get a factor tree going for 289. Now, 289, let's try 2. 2 will not go in because it's not even. Which means, let's try 3. 2 plus 8 is 10. 10 plus 9 is 19. 19 is not divisible by 3. So 289 is not divisible by 3. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6 because it's not divisible by 2 or 3. So we would want to try 7. But if you try 7, 289 is also not divisible by 7. You can see we get a decimal. So we just got to keep trying numbers until we get it to break down. So we can try 8, but it's not divisible by 8 because it wasn't divisible by 2. It's not divisible by 9 because it's not divisible by 3. 10 won't work. What about 11? Maybe 289 is divisible by 11. Let's try that. 289 divided by 11. And you can see, nope, 26 point something. So it's not divisible by 11. It wouldn't be by 12. Let's try 13. It's not divisible by 13. So we could keep trying numbers and keep trying numbers. You could go up to 14, but that's not going to work because 14 was tried would be 2 and 7. You could try 15, that won't work. You could try 16. You could try 17. Let's try 17. 289 divided by 17. And there is our answer. You can see we had to try quite a few numbers before we found one that works. So how are we going to rewrite that? Well, that's 17 times 17. So now let's rewrite this as 17 to the second, j to the second. Now that I have it rewritten as squares, we will underline and cancel the square just like that. And you can see both of the terms, the 17 and the j, will come out of the square root. Keep in mind, the j was even power. When it comes out, it's going to be j to the first, so it's going to be odd, which means it needs to have absolute values put around it. So we will be left with 17 absolute value of j. Now we're going to try a couple more. You can see this one on the left-hand side. We have the square root of 80, m to the third, n to the second. So we will need to break these up. 80 can be rewritten into chunks of 4. So 4 times 20 times m to the second times m to the first times n to the second. Now what you can see I did is I broke down 80 as 4 times 20, and then I broke down m to the third as m to the second times m to the first, which you'll see why I did that. And then n to the second stays n to the second. Now, we aren't completely broken down here, though, because this number 20 still has another perfect square hiding in it. The other perfect square that's hiding in it is 4. 20 is 4 times 5. So I am going to break that down further as 4 times 4 times 5 times m to the second times m to the first times n to the second. And now what you can see is I can rewrite this 4 times 4 as 4 squared, which is what I'll do. So this is 4 to the second, 5, m to the second, m to the first, n to the second. All right, so now we've got it fully broken down. And what you'll see is that everywhere where there's a square gets canceled and the base number gets underlined. So right here and right here. Now everything that's underlined is going to come out, keeping in mind that if it comes out of the radical and originally it started as an even and then it's odd, then it will need absolute values. So you can see this n to the second started as an even, and when it does come out, it will be odd. So you will need to put absolute values around the n variable only. So we have a 4, and then we have an m come out, and then we have an n come out, but it needs the absolute values because it started even and now it came out as an odd number. Now, what is left? We have a 5 that's left, and we have an m that's left underneath the root. So you can see our final answer is 4m times absolute value of n times the square root of 5m. I'll show you a couple more examples here. Let's look at this one. So this one, we have the square root of 5x times the square root of 4x to the third. Now what you would actually want to do here first is get everything combined into one square root. So we will start with that, and we will have 5 times 4 times x to the third. Now what we want to do here is we want to rewrite any of these into chunks that are being just squared. So you can see the 4 is actually 2 squared. So we'll leave the 5 alone. This becomes 2 squared. This becomes x. This becomes x squared. And then we have another x right here. Now what you have to be careful of sometimes is that you can have two of the same terms, and if you can, those two terms should be combined. So we will combine those, and we'll have 5 times 2 squared times x squared times another x squared. And now what we can do is cross out the squares and underline the base. And everything that you see underlined will come out of the square root. So we'll have a 2 on the outside, and we'll have an x, and then we'll have another x, and then the 5 will be left behind. Now what you see right here is we have x squared, so that turns into 2x squared square root of 5. And there's our final answer. Now I'll show you two more here. Let's do this one. So we have the square root of 5y to the third times the square root of 10y to the third. So the first thing we will do is we will rewrite this as one giant square root, 5 times 10 times y to the third times y to the third. Now if we just combine those, here's another way you can do this. We'll combine these. This becomes 50y to the sixth. Now remember, we want to break these up into chunks that are bases that are being squared. So 50, there is a perfect square hiding in there. That's 25 times 2. Now I'm going to break this up into y to the second times y to the second times y to the second. Now the last thing we want to do is rewrite 25 as 5 to the second times 2 times y squared times y squared times y squared, just like that. And now everything that has a square will get canceled, and the base will get underlined. And so you can see we have 5, y, y, y on the outside, and then the square root of 2 on the inside. Just like that. So this becomes 5y to the third root 2. And there is our final answer. Now the last one that I want to show you is this one right here. So 400, you might not know, is actually a perfect square. So we can rewrite this as 20 to the second. Now we're going to break the k up. K to the second, k to the second, k to the first. There's where we get our 5. 2 plus 2 plus 1. Now everything that has a square will get the square canceled and the base underlined, just like that. So everything underlined can come out, and everything that is not underlined will stay behind. So we will be left with 20 k times k, and then square root of k. Now the last thing to notice is these two k's can combine, and we end up getting 20k to the second times the square root of k. And there's our final answer. So there you go, guys. I hope that made sense. As always, if you have any questions, feel free to email me. Have a great day.